Okay, so this video clears up the rest of congruence and the hypotenuse leg theorem. Alright, so far the congruence theorems that we learned have been side, 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 angle, side, angle, and angle, angle, side. Now we are introducing our new friend, hypotenuse leg. So, hypotenuse leg congruence theorem is a congruence theorem that is for right triangles. The theorem says that if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then those two triangles would have to be congruent. Okay, so that bears the question, which is the hypotenuse and which is the leg? Well, the hypotenuse is the longest side of a triangle. And so here I've marked the hypotenuse. So you can just kind of see it by that, or more technically, the hypotenuse is the side that is opposite from the 90-degree angle. So you find the 90, then you come directly across. That is the hypotenuse. Find the 90, come directly opposite from that corner, and that side is the hypotenuse. The other two sides that are left are the legs. So I've picked one leg here to mark, and the other leg, there's two legs, right? This is the other one. So let's say that that particular leg is, oh, there we go. Okay, let's say that these two legs are congruent. Well, now we can see that these triangles would be congruent by the HL theorem. Now, as you look at the markings in this picture, you might notice that it looks like this is side, side, angle. And I just finished telling you that side, side, angle is not one of our congruence theorems. Well, this side, side, angle only works when the angle is 90 degrees. So because this is the angle is 90, no longer is this side, side, angle. This is, you would not put down side, side, angle. You would put HL. So this is hypotenuse leg, which is like a special case of side, side, angle. Okay, so let's see if we can apply this and determine whether or not these two triangles are congruent using HL. So when I look at this picture here, I can see that in order for HL congruence to work, three things have to happen. One, it has to be a right triangle. Two, the hypotenuses have to be equal. And three, the leg has to be equal. So the first thing I notice is that according to the diagram, the triangles are in fact right triangles, right? They share the 90-degree angle right here. And so if 90 is marked on that side, 90 must also be marked on this side, because together those two are making up a line here on the bottom. And not only are they right triangles, but they also share this leg right here, right? We have a reflexive side in the middle, and that side is a leg. And then also, it's marked in the picture given to us that the hypotenuse is congruent to the hypotenuse. So, yes, these triangles are congruent by HL. What about these triangles? Well, in this picture, I can see that I do in fact have right triangles. I have two right angles. Also, I can see that this side here would be a leg and is congruent to this leg on the other one. However, we are missing some information. The conclusion cannot be proved by HL. According to the diagram, the triangles are right and one pair of legs is congruent, but we do not know that one hypotenuse is congruent to the other. So the problem is that the hypotenuse, which would be right here, right across from the 90-degree angle, is not marked equal to the hypotenuse on the other side. So sorry, even though it looks like they're the same size, those two triangles are not, in fact, congruent. All right, let's see if we can determine whether these triangles can be proved congruent. And this time we'll say it in more of a proof-like way. The first thing is that marked in the picture we can see that side AD here is marked equal to side BD. All right, and those two sides are in fact the hypotenuses, right across from the 90-degree angles, and that is given. Another thing that's marked in the picture, oh, this is not marked in the picture, but another thing we have is that both triangles are sharing this leg in the middle, this leg BC. BC on one triangle, CB on the other triangle. That's the reflexive property, right? And that tells us that our legs are equal. And then lastly, the triangles both have 90 degrees marked in them. They're both right angles. So, because we have those three things true, we can now say that triangle ABC is congruent to triangle DCB by HL. So, in order to use HL, those three things have to be true. Hypotenuse has to be equal, leg has to be equal, they have to be right angles. So now, what postulate or theorem can we use to prove that these triangles are congruent? So looking at number 1 here, I can see that each triangle has an angle of 150 in here. So I have an angle, and then they share this reflective side, that's a side, and then they both have this 15-degree angle. So which theorem can I use? Well, this would be angle, side, angle. All right, and next up here, it looks like I have 90 degrees. Whenever I see 90 degrees, that automatically makes me think of HL. That's the one that works for right triangles. So do I have a hypotenuse marked equal? Yes, this hypotenuse and this hypotenuse. And do I have a leg marked equal? Yes, this leg and this leg. Actually, the leg in the middle is also equal, right? So really we could say HL, but we could also say side, side, side for that one, right? Okay, and then down here, this one also has two options. Which two theorems could we use to prove these triangles are congruent? Well, I see that they have the side marked equal on the outside, and they also have this side marked equal. And the third side is actually shared in the middle, a reflexive side. So I could use side, side, side. Also, the angle on the outside here and the inside, this is forming an X. These are vertical angles that would be equal. So I have a pair of vertical angles here and another pair of vertical angles here. So actually the angles on the inside of the triangle right here end up being equal. So if I use that angle, I could say side, angle, side. Or side, angle, side. So there's two different ways I could say that one as well. And lastly, let's look at this proof. Let's see if we're given these two angles are equal and this particular side is equal, can we prove that these two triangles are equal? So when you're asked a question like this, you need to break it down. First, consider all the things that are given to you, okay? And we're going to have to try to prove these two triangles are equal. When you hear prove triangles are congruent, you should know that you're going to have to prove it by one of 5 ways. Either it's going to be side, 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 angle, side, angle, 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 side, or HL. So let's break down what's marked here in the picture. The first thing we can see here, they tell us that angle FAB, which I've marked with this yellow line, is congruent to angle GED, also over here, and that is given to us. Okay, and then they tell us, well, okay, we don't care so much about angle FAB though because it's on the outside of the triangle. The angle we'd really like to get to is the one where I've put this star here, angle BAC, on the inside of the triangle because we're trying to prove the triangle angles, right? Not the exterior angle. So we can know that the angles inside the triangle are equal because they are supplementary to the angles outside the triangle. And that is the definition of supplementary angles. Remember that supplementary means adds to 180. So because angle FAB and angle BAC together make the straight line across the bottom, FC, the line across the bottom, well, a straight line is 180 degrees. So because they add to a straight line on this side and add to a straight line on this side, we can know the interior angles are equal. All right, they also tell us that angle Oh, so therefore angle BAC is congruent to angle DCE by supplementary, because they're congruent supplementary angles. Okay, so now they also tell us that angle ACB, which I've marked with two lines, is congruent to angle DEC, which I've marked with 2 lines. And they also tell us that AC, the segment AC, the line at the bottom here that I've marked in green, is congruent to CE on the other side, which I've also marked. Those things are given. Okay, so now by which postulate can we prove that the 2 triangles are congruent? Well, this would be star, green line, double line, or angle, side, and then angle. So, good, angle, side, angle. Good. And that is the end of this.